We're going to talk about integration by parts. So first what I want you to do is I want you to think about the function that is a product, u, v. Okay, so when I take the derivative, I use the product rule, and I have u, and then direct derivative of v with respect to x, and v, the derivative with u with respect to x. And we write this sometimes as u v prime plus v u prime. So let's look and see what we integrated. So if we integrate the derivative of u times v, that just equals uv. And that's the integral of u v prime with respect to x plus the integral of v u prime with respect to x. And I can rewrite that further, and I can say that uv equals the integral of u with the derivative of v plus v integral of v du. So let's say I'm looking for, I'm going to rewrite this a little bit, and I'm going to say that what I'm really looking for is maybe the derivative of u dv. So let's solve for u dv. So the integral of u dv is uv minus the integral of v du. And that is what integration by parts is. So we're going to do some examples, but before we do that, there's a couple of guidelines we want to follow that are important. So you want to do one of two things. It's an either or an or. So either let your dv be the most complicated, but it also has to fit a basic integration rule. So if it doesn't fit one, it's not going to help us at all. The other option is to let u be the portion whose derivative is a function that's simpler than du. Than the original function u. So to give you an idea of what I mean here, if my function was x squared, my derivative is 2x dx. And see how this is a simpler function? So I took the derivative again. It would be I have 2x, the derivative of that is 2. And see how it's getting simpler? And I took the derivative again. It would be 0. And what I'm trying to do is trying to get to something simple.